Start, sir.
আমি শুরু করব না, it has been started, or I'll need to talk and you will start?
I have already started this session, sir. You can start now.
Good morning, students. This is one more session of live interaction. In this session, what we will do, we will try to interact with your question or queries, whatever you have. In the Excel sheet where you have put your address, phone number, etc. in relation to this session is not having the questions. So if you have any questions, please put it on the live session chat window so that I can address those. Otherwise, it will be difficult to continue with this session. But before I start, I would like to introduce the TAs related to this course, Aircraft Structures 1, that is Mr. Bikash Kaushik and Mr. Shupen Shah. They are senior research scholars under me. So they are present in the session. Whenever required, they will come and continue as required. So as it is asked, I have also asked, if you have any doubt, please ask me. In the Excel sheet, what I have seen is what is significance of domain certificate. But this is not in purview of discussion. And the other way, if I look at domain, which domain you are talking about, which certificate you are talking about, who is going to give the certificate, all these things are missing. So it is difficult to address the question. Instead of addressing questions, since there is no question to address at present, what we can do, we can continue discussion in relation to the aircraft structures. In the last session, what we did is we did a discussion in relation to the aircraft design and where the structures come. So we have seen that this course and aircraft design is well connected, but it may not be seen very clearly if we look at it in direct manner. But because aircraft designing is a huge process, there are several stages of design. First we say conceptual design, then preliminary design, and then the detailed design. In detailed design, the thing what we have learned so far, those things come. But anyway, unless we go for detailed design, nothing we can put in service. So we have to go for the detailed design of each and individual part of the structure. And in this relation, theory of elasticity is really very important. And if I divide the two live sessions in two halves, say for the first live session we have discussed up to the displacement analysis and some approximate methods, and after that from the fifth, sixth, seventh, eighth week, if we look at, there are theory of elasticity theory has been discussed, and this theory of elasticity mm, has a really predominant role in every analysis of structure. In this context, we have discussed a problem. mm, It's a very classical old problem, that is a plate with hole. And from theory of elasticity approach, we have seen what are the stresses uh, appearing at the circumference of a hole, and we have seen that it increases even if it is unidirectional uniform stress is applied on the plate. Stress on the circumference of the hole increases to 3 times the applied stress. So it is really important that the material withstand that stress. We have also seen that it is dependent on the hole diameter, how much stress is there, shape of the hole. Keeping in mind all those, we have discussed that it is better to avoid sharp corner while there is a hole. It is always better to have a round corner. Somebody has come, Mr. N. Uddin. Sometimes in the derivation, it is difficult to understand the whole process because some of the basic concepts were missing from your derivations. It is difficult to address this type of questions. I have tried my best to cover the steps. Yes, I have intentionally skipped few steps while I have derived principal stresses from the basic mathematical concept. I have skipped a few steps while I have derived the strain displacement relation in nonlinear form. Uh, I have discussed those two tough, relatively difficult topic, I should say, relatively difficult topic, but I thought it is better to introduce at this stage. If you are not interested, you may easily skip those derivation, but at least you will come to know, or you have come to know, that there are something beyond the linear strain displacement relation. There are nonlinear strain displacement relation, and also that principal stress concept is not only something which is related to material, it comes originally from the concept of mathematics. So one more question is there from Mr. Chakraborty, S. Chakraborty. Oh, thank you for the Bijaya greetings. It is same to you. Is there any question? There is no question. So depending on that, we have derived things, and a few steps. Yes, sometimes it has been skipped to, because see, this is a problem in relation to PowerPoint, or say slide teaching and board teaching. Board teaching is always, chalk and board teaching is always preferable. There I have the scope of showing you in between steps, but here I don't have the scope. Those things you will have to work out on your own. So mm, there is no other alternative where I can show you. I can at the maximum give you some references. Theory of elasticity has been covered from many books. In some portion is from Scalar, some portion is from Wang. I think the whole problem, plate with whole problem is from Timoshenko, and the torsion problem is from Wang, I think. So it depends. It depends which portion you are talking about. I have tried my best. Or some portion is from Wang I have mentioned. So depending on which topic you are asking, it depends. And see, it is also difficult to maintain a coherence between different books. That also I have tried whatever I can. Notations sometimes become different. Sometimes introduction and derivatives, all those things become different. So it becomes difficult to maintain the coherence. So I have tried my best to maintain the coherence, and I feel this theory of elasticity, whatever is covered in this 4 weeks course, it is very small duration lectures. It is the maybe the smallest way it has been delivered. If anybody is interested to get introduced to theory of elasticity, maybe that 2.5 multiplied by 4, it becomes about 10 hours lecture. It is 10 hours are sufficient for him or her to continue for theory of elasticity. That gives a very good basic knowledge of theory of elasticity. So further from any book or any other advanced new way he can approach and continue. So uh, can you please explain how to solve strain energy due to bending loads? Uh, this is covered. Strain energy due to bending is covered in the pre-med sem, or maybe I may say that it is before the, I think, third or fourth week. Uh, Strain energy due to bending has a integral form, and you need to find out the moment at a particular section, and then you are supposed to integrate it. That's the way it is. Strain energy for bending is calculated. So in straightforward way, I can say you need to find out bending as a function of x, or as a function of the variable along the length of the particular structure, and then you have to integrate it. So that's the way it is done. Then again, yes, my next question is the same about the notations. Sometimes you have used other notations in the lecture content but different in assignments, so that was also confusing. Okay, thank you for your feedback. As I have mentioned that I have tried my best to, again, one more relatively difficult concept has been introduced here, that is the concept of tensor. So my concept of tensors makes it easier to remember. That's the reason I have introduced, and but it is difficult to understand, difficult to imagine that tensor components. So I have tried my best to do it. Many things are introduced within this. The theory of elasticity, as I have covered in 10 hours, in many places that is the total course taught uh, for a semester. So definitely it is squeezed. There are many things within this, and yes, I have introduced tensor because in some books it is there, and making correlation with respect to the problem, that you need to learn the relation between the tensor and Cartesian way of expression. So if you say it as a feedback, I'll keep it in mind next time. Whenever I will go for it, I'll try to make it more clear. So as I was discussing about theory of elasticity, better we let us discuss a little bit more beyond the theory of elasticity. Theory of elasticity is the basic analytical approach to solve problem, but in recent days, theory of elasticity is not very popular approach to solve problems. Whereas, unless we have the knowledge of theory of elasticity, the other methods, mainly the numerical methods, or more popularly we say the finite element method, those are difficult to follow. So, what we use, unless we understand the theory of elasticity, which is the basic knowledge behind the all numerical analysis method, we won't be able to do much progress with respect to the approach. So in this context, it is the basic of all numerical analysis, whatever you see, and then this basic theory of elasticity is applied along with some approximate method, uh, along with the approximate method, maybe Galerkin method, it may be some other method, or variational principle method, and accordingly we go for formulation for the numerical problem, and then we continue in a similar way. There is a question. The question is, sir, how this course is useful for GATE 2021? Uh, it depends on how do you use it. How can I say how it is useful? As much as you learn, you will be it will be useful for you, because GATE questions generally cover the bachelor's or undergraduate course content syllabus. So this is a basic part. So definitely it will help a lot, that I can say. And it's up to you how do you use it. So as I was discussing about the advanced numerical methods, so advanced numerical methods are mainly the most popular in case of structures is the finite element method. In finite element method, which is based on some approximate analysis procedure, and that analysis procedure is the basic of the formulation of the problem, and then that is put into discretized form. But while we go for precise or precision analysis, we need to consider a different model of approximation. And unless we have the knowledge of theory of elasticity, it is difficult to use the finite element properly. So while we need to go for nonlinear elements, while it is okay to use or sufficient to use the linear element, unless we have a good fundamental knowledge of theory of elasticity, uh, it is difficult to judge. So depending on those things, it is necessary to understand the theory of elasticity well, even if any you are using any finite element or numerical analysis tool. So this is something which is basic. Unless you have the idea, it is difficult. It is finite element process solves the problem, but whether that solution is correct or not, whether it is useful or not, that unless you have a fundamental of theory of elasticity, you will not be able to understand. So that gives us the basic. So that's the reason theory of elasticity gives us the basic of that knowledge, and we can continue with that knowledge to analyze any structure, whatever we see in our in our in our analysis or in our interest to analyze. It is difficult, really difficult to continue without any question or without any topic to for this long. So I would suggest you ask question, whatever I can. I'll try my best to answer or address the question. So it is something again, what I have felt, let me share with you. Uh, it used to be a thinking in my mind that mathematics and solid mechanics or structures are two different topics probably, but actually it is not. Unless you are good at mathematics, it is difficult to visualize in form of a mathematical equation the structure, the behavior of the structure, behavior, distribution of stress, distribution of strain, distribution of displacement. I have one more query, but not related to the course directly. So, may I ask? It is better to ask course related questions. This is dedicated to course. So, as I told you, unless you have the concept of slope or curvature with respect to the equation, it is difficult to visualize what is exactly represented by the equation and how it is correlating with the distribution of displacement or strain or curvature or the shape taken by the structure. So it is always better to have that understanding a correlation between those two, and to continue, how does it represents in physical form those mathematical terms. It is not only a derivation or integration, it also gives some other understanding that you should understand. Uh, so with this thing, I would suggest uh, that we let us come to the conclusion of the live session, because this live session is without any question and topic is becoming really very difficult. Okay, one more thing has come up in my mind. Let me talk a few minutes about that. That is the torsion. Whenever we talk about torsion, or probably you have gone through the torsion, torsion is generally said that it is a disc-like structure placed on one another, and it rotates considering, or uh, that rotation is prevented by the shear stress or strain, and that is the way it happens. But in general, we don't have any out of plane strain. So that is not like that. It is, there are out of plane strain. There is a nice representation of elliptical section under torsion in our course, that is solved by a famous scientist. If I remember correct, it is done by Senvenant, and then it is this warping or out of plane displacement is a nice phenomena, and we can observe it if we carry out the experiment with parallel lines marked on the specimen. uh, Sir thunderstream and voices affect airplane electric instruments as in Bermuda. Something I think related to that Bermuda Triangle and lightning effect, all those things you are talking about, I guess. Anyway, those things, there are some sealed maintained. I am not the person to talk about that, but anyway, there are some um, sealed prepared surrounding the aircraft so that it passes through the outer cage of the aircraft and it does not affect. That means it is something like it becomes a conducting body on the air. Whenever there is a lightning, it falls on it and goes. Means just the aircraft becomes a conductor, good conductor. It does not affect the inside. So from through outside, it goes to wherever it is supposed to. That is the earth. So that's the way it goes. And Bermuda Triangle things, those are mystery. Let it be mystery. There are many things in the world which are mystery. It is sometimes better to keep some mystery as mystery, better not to solve. So that will remain, and kids will get encouraged to solve those things. That's the way life goes. uh, Anything else, if it is there, anything else, any question, fine. Otherwise, I would like to conclude the session. So I don't see any more question, and thank you for participating in the live session. uh, Onudip, N Uddin, and that Chakraborty, Shiva, all of you. And with that note, let me say bye to end the second session of Aircraft Structures 1 course, second live session of Aircraft Structures 1 course. Okay, bye.